All right, so like I was saying, hello and welcome to the Cloud Native Social Hour, where we like to be social in more than an hour time frame. All right, so this time on the Cloud Native Social Hour, we are going to be talking about Cluster API and the Cluster API Azure provider. So part of the reason we're doing that is nepotism's sake. I and my buddy Steven are the co-maintainers of Cluster API Azure provider. And by that, I mean Steven is doing basically all the work and I'm occasionally reviewing some PRs. Hooray! The community works!
Hire that man!
All right.
Yeah. I'm management material already. All right, but before that, let's just have like a quick chat session. How's everyone's week so far? Or last couple weeks? Anything interesting going on? Anything in like the cloud native space that anyone wants to talk about? I know that Joe's doing Customize right now in the TGIK, which was quite interesting to watch before this, but now we're here.
Yeah, I wonder if that's still going.
It should be.
I launched a cluster with Cluster API last week, and this week I've been playing with Windows Kubernetes. So it's been an interesting couple weeks.
How's that going?
It's interesting. I'm doing the Azure route right now, which kind of like, sets everything up in the equivalent of a cloud formation. I hope to just like be able to do things a little bit more manually with kubeadm soon, but I don't know. So far, so good. I mean, past like all of the infuriating Windows stuff, like the fact that there's no killer and it goes to swap, and I don't know much about Windows.
It's been a while for me too. I think I stopped using Windows maybe like 2012 or something.
Yeah.
Is anybody doing Windows on-prem?
What's that?
Sorry, what was that?
Is anybody doing the Windows Kubernetes on-prem as opposed to Azure?
I bet there are some people. I personally haven't been doing it. The last time I touched Windows was actually technically last night when I played Borderlands 2 on my fiance's laptop because the Windows version of Borderlands 2 took an update and I can't play my Linux version anymore. So that sucks. It's a game that's 5 years old and they push an update all of a sudden. That was the last time I touched it. Before that, it was like 2009 or so. So I haven't touched it yet, but I'm excited to see how people are like using Kubernetes in Windows, right? And also having to kind of, maybe for some places, having their first interaction with Linux in their ecosystem, right? Because the control plane of the on-prem Windows or just any Windows Kubernetes, the control plane is still Linux, right? It's only the kubelet and the worker nodes that are going to be Windows compatible. So it's going to be interesting for some people, I think.
Yeah. I haven't tried to stand it up, but I assume that you need Windows licenses on each of those worker nodes, which is going to be potentially problematic for some, unless it actually would work on the pseudo-free Windows 10 licenses.
It does, and like in the Siri group, we've already talked about like the hilarious, situation of like a cluster going down due to like a Windows
licensing.
Like as far as Kubernetes failure stories goes, like that's one of the more interesting and hilarious ones.
There's stories of that, including the U.S. Navy going to DEF CON 4 when Windows license alerts popped up on every capital ship in the Navy, and they thought that it might be some
That's pretty funny.
So we actually have an open ticket around adding Windows support. Jed, if you're feeling adventurous for Cluster API Azure, I popped that in the chat.
Oh, interesting. I would definitely take a look.
So for that perspective, the idea is like you would spin up a Azure cluster and the workers would be Windows?
Yeah.
Cool. Interesting.
Yeah.
Cool and interesting.
Interesting and cool. So we also have a little doc that is just generally the kind of like the framework or the very loose agenda of today's social hour. So feel free to pop into that HackMD. And so we have a section called Twitter handles for gratuitous follow requests. So if you're on the call, you want to say hello, drop your name in there. That's totally cool.
Yeah, so the idea there is that if you put your name in there and people are feeling like up to it, they will, we can all follow each other and get, better community interaction with each other, right? All right, so besides...
It's follow Friday, isn't it?
Yeah, it's Follow Friday, right? Besides Windows nodes, has anyone actually used a Windows container yet? I haven't had a chance to play around with it.
I went to a workshop on using them that was run by Docker Inc. about a year ago. And for a while, they were doing a lot of these road shows, like in LA where I live. They had one in LA, one in Orange County. And I spent about 2.5 hours trying it. Came away just astounded at how slow it was. So in this, the idea was that you have this working legacy, and we're going to stand up a Microsoft SQL server and a Microsoft IIS server, kind of an end tier with the SQL server as the back end and IIS hosting some web content. And just to boot the freaking containers took 5 minutes. And I was shocked because I swear I could almost install Windows into a VM and boot it in that same amount of time. So what was the point?
I bet the team at Microsoft has done more work in that, or Docker maybe even, more work in that time to kind of speed things up a bit.
Yeah, so I think
doing hands-on in that era, and it wasn't Kubernetes; it was just Docker.
Docker, yeah. Plus bring your own orchestration or Swarm or something.
Yeah, with Swarm.
Yeah. Oh, Swarm.
The thing no one wanted to know.
It was, Docker was still clinging to the hope that Swarm was going to beat down that Kubernetes thing.
Yeah, and they're like, hey, you know what we should do instead? We should probably support Kubernetes on Swarm.
I think I'm still struggling with the fact that it requires like the container that you run it has to be built on the same kernel version as the actual worker node that you're running on, which to me like kind of defeats the purpose of containers altogether. Like if you can't like emulate syscalls,
decouple that, yeah,
you kind of lose the benefit of running things in a container. But anyway,
well, it's also early days for this, right? So
yeah, totally.
Remember, guys, let's try and be positive about our tech, not necessarily.
So there is actually
There's always challenges.
There's actually a demo for the Kubernetes community call yesterday around Windows containers. So I haven't had a chance to check that out yet, but I would suggest if you're interested in the Windows container support to check it out, because it's actually done by the people who really understand this. Let me see if I can find that link.
I was going to say, Stephen, if you don't mind like popping a link in the channel, that'd be awesome.
Yeah, let me see if I can dig that up.
I saw it in HackMD, yeah.
Yeah. So anything else in the cloud native space that anyone's interested in this week?
Well,
Go ahead.
China accepts came out, so that was sort of big to me because I'm suddenly looking down at 4 presentations accepted that I have. You have this moment where one, you can always fit it in, but if you get a lot of them.
So this is where KubeCon?
Shanghai.
Okay. Yeah, I was like, it's a little bit late for EU.
Yeah, those came out a month ago.
That's awesome. Congratulations, man. That's pretty cool. What are your talks?
One is on disaster recovery for Kubernetes, and part of that is Valero.
I was going to say there's a project kind of works on that.
Yeah. Well, in my mind, having worked in the backup arena a long time, there are more things to worry about than what Valero is going to take care of for you. It might do a lot of it, but it's a building block. And a lot of it is even like simple things that you'd be shocked how few times people think of it until the ugly moment happens, of just having a runbook giving instructions on how you recover. You know, I saw so many people, I did a backup startup who have instructions that they choose to put the document online and then everything's down. And nobody has a clue of even how to log into the backup to where the backups are stored to get them out. And, so anyway, that's one of them. The other one is the VMware SIG, which is the cloud provider and storage plugin for running Kubernetes on vSphere. Then the cloud provider SIG itself had a paucity of people who wanted to go to Shanghai. So really, even though I'm not in a leadership role on that SIG, I got asked if I could stand in to do the SIG's presentation. So I'm doing that. And then I'm also doing the IoT and Edge working group, which I'm a lead on. So
cool.
Yeah, that sounds like a lot of fun.
Some thoughts on your thoughts on like Chick-fil-A. I can never say that company thing properly.
Certainly, those I did IoT and Edge talks at KubeCon Seattle, got huge attendance. I mean, we're talking over 250 people in a room for two sessions. So it's That's like awesome. If you worked it out, it's like 5% of the people went to it. So, I mean, it isn't clear that the intersection of VMware and Edge IoT is viewed as strategic at this point in time. But my observation is out there in the user community, there's people who think that there is such an intersection. And right now, the people like Chick-fil-A are really, if you went to that talk, it was fascinating, but it's violating a lot of the assumptions that went into the original architecture of Kubernetes that assumed a public cloud with more or less, well, it isn't literally infinite scalability, but you know, limitations on underlying resources were not commonly dealt. Yeah, it wasn't something you expected to deal with on a regular basis. It was sort of like, yeah, eventually you might use up what you have and then you order more hardware and it might take a few days for it to get provisioned. But as a fact of life where Chick-fil-A is running on 3 Intel NUCs and that's all you're ever going to have. And some people in that space dream of running on 2 instead of 3. Maybe even 1 instead of 3. It's kind of interesting.
So this does not surprise me because every time I go to my local Chick-fil-A, they're always running out of the soup. And that's what I eat. I'm used to the resource shortages.
Yeah. They're using all the resources to provision new Kubernetes nodes on their NUCs instead of the soup.
Blame Kubernetes.
What we need now in this brave new world is soup as a service, is what I'm hearing.
I'm here for that. I'm here for this.
Yeah.
But, I mean, the tough things for running out at those edge locations are both the resource constraints, the fact that there's no backstop of any IT knowledgeable person like ever. It's sort of like, you know, the smartest guy on the third shift who might be called upon to do something. And I got involved with VMware doing the same sort of thing on vSphere. So right now, interestingly enough, there are vSphere clusters, very small ones, in every Kroger grocery store, including the brands that are like Ralph's that are part of Kroger, and every Home Depot has a vSphere cluster. And they've managed to be running these things for over a decade successfully with remote management. So pretty clearly, if you could do it in hypervisors, there's no reason you shouldn't be able to do it with container orchestrators. But the issue is whether Kubernetes is ready for it right now. And I think the answer is no, not unless you want to do it yourself. But I think the demand is there so that it will get built one way or the other over the course of the next few years.
Yes, I think that's one of the really exciting parts about the community in general, that we have these opportunities like working groups that are kind of outside of the outside of the within the governance structure, but the ability to kind of like aggregate all of these different SIGs to talk about some effort and then actually do it, right? Like it's like we talk about like, hey, these things are hard, and then people get together and like, okay, well, it's hard, but let's fix it. Right. So like IoT, having things like, finally having this conversation that comes up like every 2 years or, every year and change in Kubernetes, like, hey, what about LTS? Right. Like, is LTS even a thing that's on the table? Right. And the fact that this is actually like, we've spun up a working group, people are actively talking about it, people on the release side, people on the testing side, like everyone is like getting involved. It's like, it's exciting to see like an idea go from ideation to like execution. So
yeah. Also, LTS, for everyone who isn't familiar, means long-term support, right? So something that can be used longer than the normal like lifespan of a Kubernetes version.
Yeah.
And we do these things not because they're easy, but because they're hard. That is a phrase that I just came up with, and please don't fact check me.
But that's one of the other things that comes into play at these edge locations are with the resource constraints. There's plenty of people used to public cloud who say, sure, the update procedure is stand up new cluster nodes in parallel with the old ones and then flop over. But if you already just barely have enough hardware, that becomes problematic. So people down at IoT Edge are definitely they're definitely leaning strongly towards an upgrade in place philosophy.
Yeah, that makes perfect sense. And a lot of the challenges that they face, like I said, are the resource constraints. And I think that Chick-fil-A they've done a really good job of creating this pipeline, not just for like their code, but also for their hardware, right? That's the big part that IoT needs to, that's the actual main hard part of IoT or edge computing, is getting the resources where you need them. And so like if there's something wrong with the Kubernetes cluster in Chick-fil-A, they will ship out a new cluster. They'll just and they have like this machine set up that kind of just prints these like clusters out, and they just send them out. So the resource constraint isn't so great on the store location, but they have this like place this factory essentially that just pumps them out on a regular basis, so they can just do like upgrades. Like, oh, we need a new upgraded cluster. Boom, here you go, put that in.
I spent a lot of time with that guy in Seattle, and they don't really want to do that, send it out themselves. What they'd like is to talk Dell or some other vendor into having a catalog item that they can just order. And the FedEx truck shows up at the store, and it's made so that you just rip the sides open on the box and plug it in. And if you have enough knowledge to go unplug the old one and plug the new one where it used to be, you're likely to be successful. And that's exactly how the old vSphere ESX clusters worked at the Home Depot and Kroger stores too, that sooner or later with thousands of stores, they do break. And after 3 or 5 years, they're old enough that they're not even going to be worth diagnosing. You're at the useful life of the components. So they want this scenario where the box just shows up, and sometime during the night when the store can maybe deal with a potential outage, somebody gets instructions of, here's a picture of what this looks like, unscrew the old one, put this one where it was and plug it in, and that's all you got to do.
Yeah, that's nice. It was something I was talking with one of my colleagues about the other day, and it's kind of the same problems we had in the past are coming to light, but it's a new realm, right? It's kind of like if you look at Kubernetes, right? Kubernetes is this API. And I don't mean to take her words, but it's like Kubernetes is this API, and it's very similar, in fact, to the Linux kernel, right? And so it's like the old problems are new, but they're the same, but they're at a grander scale now, right? And so like you have this issue with vSphere at these edge sites, and lo and behold, we're having similar concerns and issues again, but at a different or grander scale, or maybe more mobile scale at this point.
Yeah, and one of the things that is interesting that I think is lacking in Kubernetes, but we could get there, but that old vSphere clusters people complained about the expense of having 3 nodes and wanted to go 2. And with ESXs, that's a fairly expensive piece of hardware, right? I mean, they're like 2U server grade Xeon hardware that are probably $10,000 a piece. So 2 of them versus 3 is a significant amount of money. So they wanted 2, and they came up with a method of putting the 3rd one in the cloud. So it's called an external witness. But I think a lot of dev work went into that to get that to work. So even the storage is, in theory, 3-way shared, but you can deal with network partitions and things by having redundant connections out over the internet to this 3rd witness thing standing in the cloud. Right now, unfortunately, I don't think that latency chasm to the cloud would be workable with etcd, meaning that Kubernetes really couldn't get there right now, or at least I think there'd be big issues. But to really pursue that edge, to, for the ultra low budget opportunities, I think there might be call for some things that might amount to fairly significant re-engineering, but it's been proven that it could be done in another context, so it's hard to say that it's impossible.
Yeah, I mean, nothing's impossible, right? It's, just how much time and money do you want to spend on it? And luckily, we have an infinite capacity for both of these things. All right. Anybody else? Anything that excited you this week or those last 2 weeks in the cloud native space?
So I guess one of the bigger things is, and I'm always excited about this as a release co-chair, that we kicked off the 115 release team.
Yeah.
The 115 release. Was it this week? Last week? This week?
It was this week, I think.
This week. Yeah. Time is passing quickly. But anyhow, so right now you should, if you're part of the upstream Kubernetes community, you're probably seeing and involved in any of the enhancements that happen for in-tree Kubernetes. You're probably seeing lots of emails floating around from the release team and all that good stuff. So like this is always a really, really exciting part for me, because like, we set the release team, and then we have this like period where we're looking for shadows, right? So we've just like solidified the shadow selections, which means like these are, some of these are people returning to the release team, right? But they're also people who are brand new to Kubernetes and have decided to contribute in this like very, very meaningful way. I say on every call where I mention the release team that I think that joining the release team is one of the most valuable experiences that you can have in participating in Kubernetes and upstream Kubernetes. So if you have the opportunity to do it, or if you just want to check out the release team meetings, you can join the SIG release mailing list, and you'll automatically get invited to those meetings. Right now we do weekly meeting for the release team, and then moving into later in the cycle, we hit like a burn down mode. So we meet on Mondays, Wednesdays, and Fridays, and then right at the end of the cycle, we had like super mega burn down mode, and we'll meet like Monday through Friday, right?
Yeah.
So if you're ever interested in checking out how the sausage is made, essentially, check one of those meetings out. Also want to shout out Nick, who is actually so Nick was a bug triage shadow as of for the 114 release, and he is now the bug triage lead for the 115 release. So
I'm both the host of your Cloud Native Social Hour and your Kubernetes 115 bug triage lead. Bam, bam. And I will not be going into these meetings with this level of energy because they're at 9 o'clock in the morning. I'm just getting coffee then.
So maybe no happy hour the week of Code Soul.
And that's, code, so bug, that's a good one. Bug triage is actually kind of an interesting position to be in because like the first half or the first like actually 3/4 of the release cycle as a bug triage lead, my job is sitting back and relaxing because the bugs haven't been added to 115 yet. So we don't really have a lot to do. But as we approach the burn down, then our job kicks into overdrive. And then we become the most annoying people in the community.
it's a very interesting time because like the way things land, right? Like sometimes the bugs aren't discovered until you land the code, right? Or like this is, you know, it's not necessarily an existing thing. It may be something that you just discover as a result of landing code. So then you're also in this crunch to like land the code and then also fix regressions and then, you know, and so the bug triage team essentially like assesses these bugs, triages them, right? It's in the name, and then like reaches out to the relevant people to make sure that we get those resolved in time for in time for the release, right?
Yeah, and we try not to be too chatty with our requests for like, hey, does this actually apply? Are you going to be working on this? Blah blah blah. We try to do like at least like once a day, like communication on these tickets. But that's how we get things kind of shepherded into the release, is just by pinging the relevant parties. And Node, like not Node, Signode is one of the people I talked to last time. And usually you'll talk to them every release. Most things touch a Node for some reason. And so
Crazy
we
idea.
reach out to like the various SIGs and be like, hey, can you guys look at this? Like that sort of thing. That's what I mean by being annoying. We're not actually annoying. We're trying to be professional, but we have to be communicative.
Yeah,
and I clearly don't have a problem with that.
Yeah, so we've also gone into these like modes where we've tried to figure out if it makes sense to use automation to solve some of these things. And I think that there's an immense value in the right human touch to reach out to people, as opposed to like we have a bunch of bots that run on Kubernetes PRs and issues that do all kinds of magical things, add labels, do merges, do squashes, tag them as you know, tag issues, retests. So like all of these things are happening, but we're like, this may be one too many. Right, you know, like, and it's more important that it's handled by a human. I think you have like having that feedback loop between two humans, as opposed to having a bot do this, it has been a lot more successful for us.
Yeah, and I got to say, like, the automation that goes into the Kubernetes releases is astounding, and I can't imagine going through a release without it. Like, it's unbelievable the amount of like stuff that's going on behind the scenes. So, and if you want to see all these things, you can join the release meetings. They are open to the public. There is a recording recording of every meeting as part of the Kubernetes, the CNCF charter. And if you want to see, like I said, how the sausage is made, this is a perfect way to do it. And I do agree with Steven that like joining the release team, or at least like contributing in some fashion, is one of the most rewarding aspects of joining the Kubernetes community, and really gets your name out there, which may be important to some people, may not be. But if you're interested at all, please sign up. And if you don't get selected for a shadow position for one release, please try again the next time.
Yeah, so I think overall that, you know, it's, of course, for every release team, we can only have a finite amount of people on the team, just to ensure that you can actually have a real connection with the shadows that you pick. But, you know, what we're trying to do overall is even in the acceptance and rejection process of the shadow selection, like we want to keep you in the community, right? If if release team doesn't work this time around, like, and we know what your interests are, we'll find work for you to do. We'll find a way for you to get involved. So I think it's, you know, for the amount of people that volunteer for as shadows, I think last cycle was the first cycle that we sent out a questionnaire, and then we kind of like signal boosted the questionnaire on Kubernetes Dev and on Twitter, and we ended up with like 200 plus volunteers, right? And you know, that's a little larger than we need for a team, right? So like people going through this process, just be aware that there are infinitely more, infinitely more rejections than there are acceptances, right? But it's not rejection, right? It's not this time, right? We're gonna find something for you to do, though, right?
Absolutely, because like we know that nothing feels worse than like putting yourself out there, giving up your valuable time, or volunteering to give up your valuable time just to say like, oh, we don't want it. And it's not that we don't want you. It's not that we don't want it, and it's not that we don't want you. It's just that we have so many spaces that we can fill. And if it doesn't happen this time, it will happen eventually. We're greedy. We're greedy for people.
Please come play with us.
Please.
So I posted in the in HackMD, that's what it's called. A link to DevStats, which is not everyone knows about DevStats, but it's kind of interesting because it's a whole bunch of it's Grafana dashboards essentially, right? But it's a whole bunch of metrics around how the community flows, like who is contributing to what repos are most active, the velocity at which issues are created or closed, our PRs are opened and merged. So a whole bunch of like really interesting statistics there. So you can feel free to pop in and poke around at some of that stuff. I was just thinking of it because of the bot interactions that we were talking about. So yeah.
Cool. I'll have to check that out actually. I have not seen that myself. Or I might have seen like a version of it. There are a lot of dashboards involved in the release process. So I might have seen some version of that.
Yeah.
All right. I think it's time to move on to the main event. Cluster API. Sorry. I was playing around with my, I have an analog like mixer at home, and it has the ability to do like FX. It'll do FX like streaming.
Yeah.
The headphones, so I would just like spend a lot of time.
Pigs in space.
I was like, cloud, native. I'm still in that kind of mood. So, all right. So Cluster API. What is Cluster API? That is a very good question. Thank you for asking. You're welcome. The Cluster API basically is a mechanism to spin up a Kubernetes cluster or Kubernetes like machines themselves in a fashion that follows the Kubernetes API. So you can schedule clusters and machines like they were pods, like they were services. Which is something that I find to be very, very fascinating. The idea of a machine as a schedulable object is really cool, but it seems like that's something that you can handle pretty easily with something like CloudFormation or the Azure equivalent, which I can't remember the name of at the moment. Or some form of like user data. What's that?
Deployments.
These things could be handled, but to make it a contract, like a API that everyone can use, there needed to be some form of governance around that. And that's where the Cluster API project kind of steps in. So Stephen, do you want to talk about that a little bit?
Yeah, for sure. So, like Nick mentioned, Cluster API is, what's the tagline? It's a declarative configuration of Kubernetes clusters using Kubernetes APIs, right? So it's the idea, again, that you can, it's like the Git book is in my head now. So just, again, imagine this world where you can leverage things like CRDs, custom resource definitions, to define the specification for what a machine looks like and what a cluster looks like, right? So if we have a homogeneous way of doing this, right? If we have an abstraction for this, that means that we can start to do this. We can start to do like really interesting things, right? We can do things like auto scaling. We can add additional functionality to providers. We can focus on not even having providers, right? Like what if I can build Kubernetes consistently, right? On bare metal, on vSphere, on AWS, on Azure, right? This is the mechanism for doing that, right? So this is a cluster. It's a SIG cluster lifecycle project, and we kind of have shared custody of the individual providers, right? So there is so if someone can pop the link for Cluster API, SIG Cluster API, that repo will give you a list of all of the current implementations of Cluster API. So off the top of my head, I know there's a GCP one, an Azure one, AWS. I think there might be an IBM one. There's a vSphere one. There is there are.
There's a Baidu Cloud one.
Look at that. There's a Baidu Cloud one. So that will give you a list of all the current implementations. There are also like, and this is a model that we have decided as an industry, as a community, really, that that we're moving forward on. So it's very interesting to see it happen in to see like company product strategy start being built around this, right? And then seeing products that you have known or maybe used, like a PKS, like an OpenShift, right? These are all of the new versions of these products are moving towards a Cluster API model, right? So what we wanted to do today was, again, nepotism. We're like, let's show off what we've been working on. So the I guess the genesis of the first, are there any questions about cluster API?
Yeah, that's a good.
Right. I don't want to speed ahead if there are questions.
Or not just even questions, thoughts. Like, is there something about cluster API that you're excited about? Is like the idea of stamping out clusters in this way like interesting to people? Like, how are people like thinking about using this? Right. I'm curious to hear what you guys think.
So from my perspective, I come from Pivotal, and I have long hoped for a Bosch replacement, given all the kind of pain that Bosch has caused. So this is very exciting for me. I didn't hear, is there a GCP provider as well?
Yes.
Yes.
Okay, cool.
Yeah, we forgot to list it.
Yeah, but it's, I mean, I think it's listed on the implementations. So
yeah, so it's like every major cloud and some of the fringe clouds, the clouds that are becoming mainstream.
Hipster clouds.
Yeah, I was like, what's that?
Single.
They call those hotels
Boutique.
Yeah, the boutique clouds. Every time you spin up an instance, they play jazz. It's great.
So one way to look at it is it provides a really nice declarative model, so it matches sort of, if you've started to mind the declarative approach and you love it for all the rest of Kubernetes, here's a declarative model for declaring what you want to happen as the type of cluster you specify, and then that's what should go happen, correct?
Yes, so it's very, very meta. So when you start digging into some of the code, you're like, whoa, what am I?
Yeah.
And then, you know, I mean, the one thing eventually, if you could help to understand, okay, well, there's the base repo, and then you've got the provider repos, and I'm just trying to get a good understanding of the relationship.
Yeah. So the base repo is kind of like, this is how we're defining the API that will define machines, that will define clusters. Like, this is how we're defining these things. The provider repos actually have the mechanisms to make that happen, right? You're like, I want this machine to happen. And if you try and use the Amazon provider, the AWS provider, and GCP, it's going to be like, yo, that's not the same thing. I don't know what you're trying to do. So there are some mechanisms that exist specifically for these providers that those sub-repos provide. Now, there is some talk in the community about taking some of the work in the specific providers and making them abstract and then moving those back up to the cluster API provider. Like we said, the definition of a service, definition of a machine, those things should be contracted across the providers, right? At least that's my thought.
Yeah. So there are also, there are also like helper tools and things that are littered across each of the provider implementations that could probably, like let's not duplicate the effort. So Chuck has worked on a like a releasing tool, right, for the cluster API for AWS, right, and then there's a certificates package that both AWS and Azure implement, right? That could easily just be something that's implemented on the top level cluster API, right? And then there's the kubeadm and init and join configurations and bootstrap mechanisms, right? That again, that could be abstracted to the top level cluster API packages. Right.
Yeah, so something you'll see that's kind of interesting in the cluster API repos is that the providers themselves create or define the cluster CTL command. So you know how there's like a kubectl command? There's now a cluster CTL command to do cluster control. Each provider at the moment has their own binary because it has the specific commands to create those things. That will eventually, hopefully, move up to the cluster API repo itself.
So if I'm understanding the history correctly, I think part of the reason of there were initially a few providers that were in the top level repo, and they were kind of split out to speed up velocity. I think that once we find consensus across the providers, or we get to some close to consensus, close to quorum about the way certain patterns should be built, I expect to see some of the provider information or provider specific stuff fold back into the top level. So
Cool. All right. Any other thoughts or questions on Cluster API? Okay.
Cool. So now to talk a little bit about the genesis of Cluster API for Azure. So Cluster API for Azure is actually one huge shout out to Platform 9, and I'm sorry there is like a ambulance in the background.
I actually can't hear it.
Oh, perfect. Well, so huge shout out to Platform 9. So they initially started off the work for this Azure provider. So I have this like curious habit in the community of ending up on Azure projects. So initially this goes back to CoreOS, where I was working on a project and they're like, hey, we need to support Azure, and we're like, okay, all right. So ended up like working on that on site at one of our customers, and that was kind of like my lead into working on some of the Terraform community stuff, and then also working on some of the upstream Azure stuff. And they were like, hey, you want to share this SIG now? So invariably, whenever something Azure related comes up, I will end up in the mix. And so I was like, okay, well, Cluster API is happening. I wonder if we have an Azure implementation, right? And started poking around, noticed this Platform 9 implementation, and we. So the curious bit about it is the Platform 9 folks. One of the guys who was the primary maintainer, he was an intern. So he is back at school now. And on the Microsoft side, there was also, so Microsoft got involved in the Platform 9 implementation, and they also had an intern working on it, and he's back at school now. So we were like, okay, who's actively maintaining this? I was like, I think that, there should always be a goal to minimize effort. So where possible, like we shouldn't be creating a new provider if this is workable, right? So kind of made some inroads to migrate the Platform 9, got their permission, of course, and access to the repo, and then migrated this into the Kubernetes SIGs org, right? So the Kubernetes SIGs GitHub organization is essentially the top level organization for all of the for what should be all of the SIG related work, right? And then we kind of got to work. It was so I was just getting ready to leave Red Hat. I think Nick was on vacation at the time.
I was on vacation.
Yeah, and I had a few miles left to like hit status on Delta, and I was like, you know what, I'm gonna take a trip. So I ended up hanging out with Nick and his fiance over like the post Christmas or
It was so I was visiting my fiance Sheila. Shout out, love you.
Shout out to Sheila.
Shout out Sheila, love you, girl. No. I was visiting her. We were visiting her folks for Christmas, right? And it was I was there the week prior, and then you came the following week. So in between New Year's and or no, actually, it might have been post New Year's as well. I think you came post New Year's.
Anyway.
Yeah, sorry, that doesn't matter.
Yeah, I think it was into New Year's.
What am I doing?
So we were like, hey, I think it'd be really curious for us to have a project that we can work on as like one teammate and two friends. I was like, I'm looking at this Cluster API thing, and I think it'd be kind of like, I think like this is the direction that a lot of people are going to be moving in, and it'd be nice to be ahead of the game there. Just like one for personally, and two, like it's also a strategy play, right? So we spent a week hacking some of this out and watching binge watching Steven Universe.
Yeah, a lot of Steven Universe.
And got to a place where I think it was close to workable. We refactored quite a bit of it, and shout out to the AWS folks, everyone who's working on Cluster API AWS. So Jason and Nadir and Andy and Tim Sinclair and like all the people who have been laying down really solid roots and building like something that we could essentially steal.
I do want to give a big shout out to Jason D. Tiberis. He gets on calls with us all the time after hours to talk about stuff, and he's just awesome. What a great mentor and a great friend. Like, shout out.
Word. We love you, bro. Yeah, so over the last few months, I would say end of December into where we are now. Apparently, I have no concept of time. We've gotten the repo to something that's spun up just control plane. If you knew the right buttons to tweak and things to play around with in the repo. Otherwise, it was broken on master, right? So now, not broken on master. Now we have a release process. We have more than just 2 contributors. We've started to talk to. We had a good chat with a bunch of the folks at Microsoft and have onboarded contributors on the Microsoft side, and we're starting to talk to Red Hat as well. So like slowly but surely, like this is turning into something that was I think like largely an intern and a hobby project into something that is actually like a real implementation. So I'm really proud of some of the progress that we've made. I don't want to keep yapping about it though. So if there are any questions, I can field the questions and then we can go into a demo.
Yeah. And I'm really proud of you too, man. Like the work that you've done on this, the Azure provider is Herculean. Like plus your day job and doing this, like it's been awesome. You've done a huge amount of work in a short amount of time. So kudos to you, man. That's awesome.
So Btdubs, we're looking for contributors. We're looking, like to continue to plug ourselves. We're looking for contributors. So anyone who's interested in getting involved, we can.
Pull requests are definitely
welcome. Our bug reports.
Bug reports are definitely welcome.
So it looks like Ace is actually on the call, and he was having some trouble earlier in the channel. I believe I introduced the regression.
Still playing around with it, but nice to be here.
All right.
So what happened? Do you mind talking to us about it a little bit?
Yeah, I was actually just getting introduced. I was trying to just build it and create a cluster. Looks like there were some build issues maybe, but it's still just poking at it, trying to get a cluster up now actually. So you guys know.
Yeah, so we have this process that there's like a deep copy generator that runs in, so usually like you have to remember the file to go to. I think it's package APIs, api.go or something. And within that file is like a snippet of the code to run, right? So I took that out and turned it into a make target. And apparently I didn't do that right. Because I've broken part of the generation. So I think that was in the last PR. So I'll clean that up probably after.
Yeah, I mean, I was looking through it. I didn't see anything crazy wrong, but it looks, I'm not as familiar with you, obviously, so definitely appreciate it.
Yeah, for sure. So I think right now, if you use the binaries dev target instead, you should be fine because it doesn't run through that generation process. It just does the go install.
Yep.
And also, if you have any issues with the Cluster API Azure provider, we are taking PRs and bug reports, as I said, but we are also in the Kubernetes Slack channel as I think it's Cluster API Azure, right?
Yes.
Yep. So we are in Cluster API Azure. Yep. So look for us there and talk to us about Azure stuff and Cluster API stuff.
Or how your day's going, whatever.
Hey.
We're friendly. All right, so I am going to share my screen and
please do.
So we also decided to wanted to talk a little bit about the roadmap. We had a lot of stuff that was MVP, what we considered MVP. So the project's kind of broken into, we have multiple milestones. The milestones that I consider in my head are baseline, MVP, V1 Alpha 1, and next, right? So the baseline milestone is kind of like, okay, we've just migrated this project in. It needs prow plugins for, it needs prow plugins. It needs an owner's file. It needs security contacts. It needs like bug templates and issue templates and all these like little things that would go into making it a Kubernetes project. That's what I consider that milestone. So anything that kind of fits that mold, oh, we've got to tweak some tests or something like that. Like that would fall into the baseline milestone. The next milestone is MVP, and MVP was kind of created as a milestone to say like, this repo is broken right now, right? What are all the things that we have to track to get it to the point where I can run and build a Cluster API Azure cluster from master all the time, consistently, right? So all of the stuff, so I think I actually recently closed the MVP milestone since all that stuff is done now. The V1 Alpha 1 milestone is a call out to the V1 Alpha 1 spec for Cluster API, the upstream Cluster API. So tracking all of the bits that run into making sure that we're compliant to that spec, right? So that is actually, Cluster API, the top level Cluster API hit a major milestone. Was it last week? Was it last week or before that? But they cut the 0.10 release, which is their V1 Alpha 1. So we now have the first part of a stable alpha API. Feels weird to say stable and alpha in the same sentence, but
we're approaching stability, but it is still in an interesting place.
Yeah. So I'm gonna go through what it takes to build a cluster, and make my screen a little bigger for you. Right. Everyone can see that, okay?
Yep.
Cool.
Looks great.
All right. So first things first, I'm going to just edit some of these environment variables. So capc aug, that is going to become, I don't know.
You can also see how many times that we tested making Cluster API. We're up to 50.
So we're going to call this one Rainbow Sparkles. And cluster name. So, I mean, a lot of these variables are pretty self-explanatory. So this one is setting the resource group that it's going to create in Azure. So anyone who is not familiar with Azure or more familiar with AWS than Azure, Azure has the concept of resource groups, which is pretty cool because it allows you to encapsulate a set of resources within this like logical grouping, right? So if I am playing around, this is a perfect example, right? If I'm testing out a bunch of Cluster API Azure clusters, and I want to destroy them very easily. If anyone has tried to destroy a VPC in AWS, if like, oh well, these rules are connected to this or this IG, like this internet gateway is here, and like you run into these like very interesting things. Where being able to consolidate these into a single resource group is pretty cool because I can just go and delete them easily, right? I can also use the resource group to scope the access that I provide to certain people, right? So certain people can't create resource groups, or certain people can operate into certain resource groups. So there's a lot of flexibility around, one, the organization, and then two, the way that you build permissions in Azure. So the Kubernetes version is setting the Kubernetes version. The manager image tag, because I'm still kind of playing around, we're pre 0.20 cut right now. I keep saying I'm hoping to cut it this week. There is a refactor that I want to land before I cut that, and that should add support for existing resource groups as well as existing virtual networks. I would love to land that before I move on to the next version. Cluster name, again, pretty obvious. And then finally, we're going to run this make manifest target, right? To see what's kind of happening behind the scenes. At the end of the day, I think everything in Kubernetes, it's kind of funny that there's always like a bash script hidden somewhere that does something that you may or may not expect it to do. So one of our targets actually will do an environment substitution of a bunch of these environment variables, right? So we've got a standard control plane machine type and node type, Kubernetes version that's set, the cluster name, and some of the things that we saw before. If you don't provide a resource group, it will take some random string that I decided to be clever and do do capy dash that random string, right? Then some additional substitutions around. So this kind of like preps the Azure credentials to be base 64 encoded and then popped into a secret, right? And then that secret is mounted into like the manager, the controller manager for Azure provider. So more things around these, like templating for these files. So there's a cluster file, cluster network spec, machines.yaml, right? And these are all I mean, when you see the file, you're like, oh, wow, this is Kubernetes, right? This is, it's very, it's very similar to, building a manifest for, a manifest for any resource you would normally use in Kubernetes, right? And that's what's really powerful about this in general, right? That you can take all of the knowledge that you've been gaining in Kubernetes and apply it to actually building Kubernetes for yourself, instead of worrying about deployment pipelines and whether I'm going to need, like how am I going to provision these systems, right? That kind of goes away. So if we see, we can check out this credentials.yaml template, and you can see, as I said, it's pulling these environment variables and popping this into a secret. From the clusters.yaml side, we can see we're setting some CIDRs for the services and pods network, the service domain, and then finally some of these environment substitutions again, right? This is the provider spec. And we're essentially providing it resource group and location, right? So the things that Azure would need to understand to actually instantiate resources within a region. And then finally, the machines.yaml, which again, a lot of environment substitutions for the cluster name. But then you can also see this spec is like, hey, I want to know what the VM size is going to be. I want to be able to choose an image. You can't currently choose an image, but this is probably something we'll look at doing later. But then, choosing the OS disk size, the SSH public and private keys. So all the information that I would need to know to, again, create a machine within Azure, right? So enough talk.
And then wait, stay there, Stephen.
Yeah.
So something I wanted to talk about a little bit. I know you're doing a demo, but taking a look at that file. Oh, okay.
Oh, sorry. Let me go back.
It's all good. So taking a look at that file, it looks exactly like a Kubernetes manifest, right? That's the thing that I find to be so cool about this, is like that looks exactly like the way you deploy like a pod, but this way it's actually affecting something in reality. It's a machine that you're creating, right? And I think that's really awesome. So I just wanted to call that out.
Yeah, it's this like super tangible thing. And, if you want to get, if you're more curious about what some of this stuff looks like, we actually have, the types defined, right, for the API, right? So, this is a struct that includes like, okay, well, I want to know the key pairs for, for different resources, the admin kube config, right? And then also, how do we define a VNet, right? How do we define a network in general? A network is something that has a VNet and multiple subnets, right? Or that's our consideration of what the network is, right? And then, what's in a subnet? What am I expecting to get out of this struct, right? So the ID of the subnet, the name, the VNet that it's tied to, right? So we can manipulate all of this data. This is presented as the v1 alpha 1 API for Cluster API Azure, and then we can manipulate all of this data in the lower level packages, right? So that's kind of what the cluster spec looks like, and then the machine spec over here is again all of the stuff that's getting spit out in that YAML template is the stuff that we're looking for, right? So an image is a struct, and the struct contains the publisher, offer, SKU, version, all the things that again you need to create to create this type of resource within Azure, right? And this is part of the reason that it's not the machine spec per se, right? But it's the Azure machine provider spec, because this is something that we can give a general idea of what some of these things are supposed to look like, but when it comes down to it, every provider has a different implementation of these constructs, right? So you can't easily abstract that away to the top level cluster API, right? So that's the reason for having these separate specs. So any questions there? Cool. All right. Cool. All right.
Cool.
So I'm gonna run all of these in tandem and make the screen much bigger, right? So just a explanation of what's happening here. So the make clean target is going to essentially, when in the manifest generation, we create an out folder within these examples, right? So it includes like information about that cluster specifically, right? So you can see that these cluster CTL create cluster calls are actually calling out to the out cluster, out provider components, and then out add-ons and out machine, right? So all of those things, we want to make sure those are clean before I do another run, right? So that target just cleans up directories that don't need to be there anymore. The make manifests, again, make manifests runs that generate that YAML script. So it will spit out all of these things that I was just talking about, right? So provider components, the add-ons, the cluster .yaml and the machines .yaml, right? So make kind reset is a target that will delete a kind cluster that's named cluster API, right? So kind, I will not go into. I don't think we need, like, I think recently there have been a bunch of reviews and blog posts and meetups around kind. I think it's a really cool tool, really powerful, allows you to use Docker to spin up a bunch of Kubernetes nodes, right? And then the way it's built allows you to do like really cool things like edit the types of clusters that you expect to come out of kind, side load images that you may be testing at the time, and one cool part about it is it's fast. It's pretty fast. So this allows us to iterate pretty quickly over like spinning up clusters. Essentially what happens in this flow is we instantiate a bootstrap cluster, right? So the kind cluster is our bootstrap cluster, right? And we deploy the cluster API cluster API controller manager to that cluster, as well as the Azure provider controller manager, right? The Azure provider controller manager is the one that contains all of the doodads to create actuators and reconcilers and all that stuff, all of the stuff that goes into creating. And I can poke on some of the actuator and reconciler code as this is actually running, but I will kick it off since I think it will take, if everything goes right, it'll take under 20 minutes. So I want to say 18. Let's hope for the best. All right, so you see the things that it's removing. Now it's generating the assets. There is a lot of Bazel. There's a lot of quite a bit of Bazel happening in the background. All of our, I would say a vast majority of our make targets will call out to Bazel. So part of the requirement is to learn a bit of Bazel. I've gotten to the point at this point, like I've gotten to the point where we now need to, we're refactoring some of our interfaces. So we need to write different tests, which require mocks, so I'm now going through the pain of like understanding how the mock generation process is happening within Bazel, and rewriting some of that stuff to generate mock interfaces. So that has been part of my day, the painful part of my day.
And shout out to Nadir Jiwan. A lot of our Bazel stuff is based on the work that he did for Cluster API AWS. He is a genius.
Genius. All right, so we've created the binaries now, right? So I have a cluster CTL. I've got a manager, right? And we are going to be off to the races after we run this command, right? So this command says, I want to create a cluster. I want, don't go too crazy with the verbosity. The provider that we're going to target is Azure. The bootstrap type is kind. We technically also support Minikube as a bootstrap type. I have not tested Minikube in quite some time because kind is just that much faster. So if you are a Minikube person, feel free to play around with it. I spend most of my time using kind. So.
It's amazing how much faster kind is than Minikube.
Right, so you see it's creating the kind bootstrap cluster right now. As you noticed, I have like 3 terminal tabs open. And the reason for that is, so right here, I just want to watch the pods that are coming up. So I'm going to wait till it does a thing, till kind actually pops up, right? And Get some Jeopardy music going or something.
Da, 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 da,
All right, so kind is off, right? Oh no, what did I do? I forgot to copy the config. Yeah, right. So we can see each of the some of the assets that are coming up. You can see that it's using kubeproxy, obviously, Weave, core DNS. And then this is a cool command, like just adding a watch to a get command. You can see when certain things are popping up, right? So I like to do that just to see how long it's taking for these assets to come up. We can see that the Azure Provider Controller Manager is now running. So that's where all the magic happens. So over here.
Did we talk about the pivot?
I'm going to.
Okay, cool. Sorry, I didn't mean to preempt.
No, it's cool.
I was just like, oh crap.
What have we done? Oh my God, this is embarrassing. That's not great.
Resource group of type B1 alpha resource group.
I see what I did. What happened here? All right, cancel that. Oh, I see. That's an old version. That's, right, okay. We're gonna step back a second and actually build these images.
Oh, the image you have locally is
the image that I targeted is actually the one where I'm writing the existing resource group logic. So it has a struct that doesn't exist in this version of the code.
Okay.
Yay. Okay. Stepping back a moment and shooting this in the head. Make kind reset. All right, pretend you didn't see any of that stuff.
Well, that's actually kind of the fun part about kind. As you can see, like it's easy to reset your environment back to a place where you can test again.
Yep. And like what's really cool about that is I have not manipulated my environment in any way. All the stuff that was happening within the context of kind, right? So it's not like, oh, I've switched this DNS resolver, I've done this thing, and I have to reconfigure my local like this. It allows you to have a consistent framework for running Kubernetes and for testing Kubernetes. So it's kind of cool to see that some of this is starting to be used for our actual testing framework within like Kubernetes test infra, right? So like you can optionally swap to using a kind job now, which again, they're faster. Like do it if you use tests, if you create tests for Kubernetes, like use kind, please. So right now this is just doing a Docker build. And if you want to see the Docker file, no magic, it's just a multi-stage build, right? We're using Golang 112.1 because it's good to be current. And then we're copying it into a GCR distro list base image, right? So there's an overarching effort in the community to move core images to distro list base where we can. And it's, again, good to be ahead of the game. So we switched over in PR not too long ago. Docker build, taking a while.
I kind of fit the Docker build, taking a while. Building all those Dockers in your mind. And this is the content you can appreciate on the Cloud Native Social Hour.
We should look at using BuildKit. I wonder whether it'll be a lot quicker.
Oh, I wonder.
Like the new backend for Docker for building.
Good question.
Because it can do a lot of this stuff in parallel for figures that doesn't depend on each other.
That's a good point. Yeah, it sounds like you wanna spike on that.
Sounds like someone's got some free time.
I know, right? Well, BuildKit is really cool. I mean, like, shout out to my to my past life colleagues at Docker, like the build kit backend for Docker build is now like super fast and super quick.
Yeah, maybe it's something
Crazy efficient.
So we're using Quay right now to store our images. We will eventually be moving to GCR. The CNCF maintained GCR right now. This is just my Quay account with an organization called Kate Staging and holding those controller images. So we can see I just pushed up that version. And you can see that like there have been quite a few versions, and these are not like all of the ones that have been like not including all of the ones that have been deleted over the past few months. So, all right, now we've got a working image. Yay! Hopefully. Okay, so one more time.
There are times on this program that I wish I had a soundboard. I was gonna do the one more time.
Just get that in the budget. Put it in the studio.
Bam, 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 bam.
It's all it
It's all that will
it would be. Just,
It's like
Why does
we
no one
can't
attend
stop
this
now.
anymore?
Viewership
three
has
of us
gone
at the
massive
soundboard.
down.
Why?
So Nick had mentioned a pivot, right? So there's the interesting part and where it gets even more meta, right? So what happens in Kind is, like I said, we deploy these two controllers, right, to handle some of the cluster API objects, and then after the control plane comes up, the cluster CTL command actually drains that bootstrap cluster and pushes the objects out to the cluster that we've just created in Azure, right? So functionally, your cluster becomes a management cluster for other Kubernetes clusters, right? So very meta situation. And this is something I didn't really understand about the flow when we were in MVP mode, because I never got to the point where cluster CTL would complete successfully. So once it actually did, I was like, oh, it's doing all this crazy stuff, this crazy cool stuff, right? So we then push the cluster API controller manager and the Azure provider controller manager out to that new management cluster, and then you can manipulate that cluster from within that cluster, right? So you've bootstrapped the cluster. So if anyone has ever worked with like Tectonic or like Bootkube, that's exactly what we did, like just using different constructs, really. So it's like we create this bootstrap cluster and then take the assets that we've generated from that bootstrap cluster and kick it out to a different cluster, right? So it's managing itself. Essentially, you've built a Kubernetes cluster that now manages itself, and then like at the end of the process, Kind cleans up, destroys. Cluster CTL cleans up Kind, destroys the Kind cluster, and then gives you instructions about applies any add-ons for the cluster, and then gives you instructions about how to access the cluster, right? Where the kube config is, right? So the kube config gets spit out in the root of that directory. We can see a few things are happening right now. Lots of things are happening.
Yeah, error.
Could you describe that flow one more time? I'm just trying to play that back. I mean, you've got the Bootstrap cluster, which is the Kind cluster, and then as part of that, you're going to get the actual cluster up and running, the one that you're trying to actually do with all these commands, and then I lost you, I think.
All right, let me see if I can change the view or change the camera in here so I can pivot the camera to the whiteboard that's over here. Actually, I can do it over here really quickly. Can you guys see this? I hope this is erasable. Suddenly,
it's just a window.
It's not actually. Whoops. I assumed that it was writable. So, all right. Well, too bad this is recorded.
I was like my primary goal for this recording was just to make sure I didn't expose my credentials. I was like, if I can do that, you see, I set a very high bar.
Okay, so never mind. I can't do that.
Okay.
There's no controls in this room. So Stephen, go ahead and talk about the pivot again.
Yeah, so what's essentially happening is, like, now that we can describe these things as Kubernetes objects, right? And now that we're building, we're building controllers essentially, right? So controllers, they're, you turn them on, turn them off, you kill them, you don't kill them, whatever, right? They're supposed to essentially have some flow that they continuously reconcile, right? So the cool part about being able to describe your cluster as and your machines as objects within Kubernetes means that it's basically just YAML. I can kick it somewhere else, right? So after after the cluster successfully, or the control plane successfully comes up, it transfers the cluster's information and the machine's information over to the management cluster that you've just created, right? So that management cluster then instantiates that reconciler flow again, right? So it's like, hey, is there anything else that I haven't created yet, right? And at that point, it recognizes that it hasn't created the node, right? So the node creation happens within the management cluster that's in Azure, right? Was that cool? Yeah, Brad?
Yeah, I guess I didn't realize there was that extra step of the management cluster. I guess I thought the Bootstrap cluster was doing all the management, but it sounds like there's 2 levels of management cluster from what you described.
Yes.
The Bootstrap cluster is temporarily the management cluster, and then the pivot occurs.
Like the first time I learned about this, I thought exactly the same thing. I was like, wait, how many Bootstrap clusters are there?
Do I need? Like,
right. But I think in some cases, right, like that original, like if you're not going to pivot, that original could be long-lived, right?
Mm-hmm.
But like,
exactly.
I guess the typical flow right now is like the Bootstrap cluster A creates like cluster B, pivots all of its information to cluster B, cluster A dies, and then cluster B can be used to create cluster N.
Yeah. Exactly.
Okay. So there's like 3 levels, but cluster A is very short-lived.
Yeah. I mean, if you wanted to, you could have an infinite regressing Bootstrap cluster.
Yeah. It's like, I heard you like Kubernetes clusters, so we built a project that allows you to build Kubernetes clusters in your Kubernetes clusters so you can Kubernetes while you Kubernetes.
I'm going to make a new project called Kubernetes and Kubernetes in K3.
Nick, you can leave. You can.
All right. Bye, everyone. It was fun.
So I just want to point out some of the stuff that's happening right now, right? So we have some of the stuff that did happen. So we have started 2 reconciler flows, right? So I'll show you in the code what's actually happening, right? So this reconciling machine and then reconciling cluster flows that are happening, right? So the cluster one is the one that we care about first. The cluster one will generate certificates. One understands, like, a lot of the objects that get used in the machine controller are dependent on the cluster objects, right? Which is we actually import the cluster scope into the machine scope so that it has access to all of that information. And again, I'll show you that in the code in a bit, right? So we have some initial failures here because essentially, like I said, some of the objects, it's a reconciler loop, right? So some of the objects may not exist at the time that they get asked for. So this is a machine, this is the machine actuator getting ready to create a machine, but before I can create a machine, I have to create the NIC, right? And it's looking to create the NIC within the CAPC Rainbow Sparkles resource group, which does not exist yet, right? The resource group is about to be created within the cluster actuator, right? And now we see that it's failed to update this machine, and it's failed to update the machine because it didn't have the NIC, right? And the actuator is like, hey, I'm just going to try again in a minute. Is that cool? And goes and just, and like, I'm going to hope I have the information by then, right? So continuing down the line, we've got, we see we've successfully generated some certs. We've generated some kube configs and some discovery hashes for kubeadm. Now we've created the resource group. Resource group is there. Now that we've created the resource group, we can start instantiating the rest of these things, like the virtual network, adding the appropriate, creating subnets as a result of that, adding the appropriate security groups to the control plane and the node subnets, creating a route table for the node, the node subnet, right? And so that's like the basic flow, right? And right? So now we're creating internal load balancers, and all of this is listed out as, these, you can tell exactly where it's happening in the code. Thank you, Klog.
Yeah, I love that. Because
Um,
before it'd be like, okay, where did this fail? All right, grep-r failure,
Right.
like error
hope I didn't
message.
clear the terminal or something.
Yeah.
Like, oh, that was 5 clusters ago. Where was that error message? But so internal load balancers, the public IP is the public load balancer, right? And then the reconcile is essentially complete, right? It's running back through it because it likes to have fun. I probably need to clean up some of that logic, but now we're at the point where the machine is ready to go, right? So we're looking at the virtual machines.go is saying, I'm going to create the NIC. I can actually create the NIC now because the resource group exists. And from the NIC, I can start to create the VM, right? So the VM is coming up, and right now it's running through the startup script, right? So we can inspect what's happening in the startup script too. But if we are, so if we look at this cluster CTL call, it's just waiting. It wants to see when that cluster, when that control plane comes up, right? And it signifies that the control plane comes up by annotating the control plane with like cluster API Azure equals true or something like that, right? So that's so once that happens, if we want to go over here and say copy, what am I looking for? What am I looking for?
Rainbow sparkles.
Huh?
It's rainbow sparkles.
Rainbow sparkles. Examples, Azure, out, SSH key, right? That is a private key for the all of the nodes that all of the nodes that we're going to be SSHing into. That's an SSH. We'll call this rainbow sparkles. I can't believe I named it that. So now we have the SSH key that we need. We also need to understand what I'm SSHing into, right? So rainbow sparkles, you can see all these assets have been created. What we care about is the reading is hard. We want to get the DNS name for the public IP that's attached to the load balancer, right? Reason being is the load balancer has a NAT rule that is forwarding SSH into the control plane, right? So SSH-I SSH rainbow sparkles, right? The user is Cappy, and that's that, right? I'm in. All right. So just to show you where these scripts end up, it's var lib wa agent custom scripts download 0. Right. So here we can see that it's downloaded container D. It's got a script here, a standard error and standard out. If we want to look at what the script is really quick, right? Pretty. Oh my God. I said I wasn't going to. Oh my God. All right.
No. Oh no.
Oh my God. All right. So the script includes credentials that I now need to burn to the ground.
All right. Well, we normally won't edit these videos when we release it to the public. We will edit that part. Someone make a note to edit out the private key.
Was it not like 5 minutes ago he said the one thing I can't do? It was like he just tried as hard as he could to go.
That was your one goal, Stephen.
SH in. He had to go find the right record. He had to find the right file and pop it up.
And regrettably for him, I have a photographic memory.
Happy Friday.
I'm going to remember.
You're going to tweet out his private key.
I'm going to spend the rest of this meeting typing out the
one character at a time.
A, Z, 1, 6, lowercase a.
So what I actually
like
wanted
he scrolled it up so you could see the whole key. I'm just saying from an outsider.
So
Hey, man,
what I wanted to show
we have
you
fun. We
the
have fun here on the Cloud Native Social Hour.
sometimes we expose credentials. So so it's doing a bunch of installs of the packages required, the CRI, CNI, all those good things, kubelit, the kubeadm package, and kubectl, right? At this point, it has all of the information that needs to instantiate a Kubernetes cluster using kubeadm. So this is actually the kubeadm run that's happening. And then at the end of the run, we've got, at the end of the run, you see the information that you need to grab the kube config, and below are some information about the bootstrap token. So that is that script that, so brilliant. Can't believe I did that.
It's all good. It's all good.
All right. So over here, so we see this this follow that I was doing on the logs has stopped, right? And the reason for that is that that Azure provider controller manager has died, right? So this cluster client has killed off that Azure Azure provider controller manager because it no longer needs it, right? It has the information that it needs. It's saying, hey, this is the pivot phase now, right? So the pivot phase generates the list of assets that are on the cluster that it needs to move somewhere else, that it needs to pivot, right? So we can see that there are no machine classes to care about, but there was a cluster that it found, Rainbow Sparkles, right? So it's now moving that default, that Rainbow Sparkles cluster that's in the default namespace out to the target cluster, the cluster that we've just created, right? And it's checking for machine deployments, machine sets, and then finally machines. It's found a machine, and it's transferring the information about that machine out into out into this new management cluster, right? So once that happens, we realize that the machine list that I've transferred over to is actually a list that includes one more machine, right? And it's the node, right? So it's right now it's like, oh, hey, I've got one more thing to create, right? So it's going through the creation of the node right now. And if I get out of here, all right, so what am I looking for this time? Right. Kube config, right? So it's dropped the kube config in the root of the directory, right? I am, oh my God. Oh my God.
Oh no.
I posted it on Twitter.
Okay, all right. We're not going through the history anymore.
This is now a circle of trust. We're all in this together.
Yeah. The suicide pact.
Nobody's gonna say a word. Nobody's gonna try and,
Like, can we get a list of everyone on the call so we know who?
Yeah.
How can I make this even better? Export my Azure secret.
It's one of those bloodos where the last one who dies gets to open up the secret or something.
Yeah. And the ink is faded or something. It was actually a coupon and the coupon's expired. So we can see it's running back through this reconciler flow, right? So again, I should be able to use this like any controller manager in Kubernetes. I should be able to use it. It should be able to start its flow anywhere and be able to get to that desired state without having any expectation of like synchronicity, right? So it's running through all of those steps that you saw before, reconciling the cluster, the certificates, making sure the security groups are in place, the subnets. It's found a VM for the machine, right? And it's starting to do an update for that stuff right now, right? So what's cool about, again, we said these are Kubernetes objects, right? So if I look at, if I just do get clusters, right? I can now see that cluster as a Kubernetes object, right? And if I want to go a layer deeper, describe rainbow sparkles, well, I should say cluster, right? Gives me this information about the status of the cluster, the bastion that does not exist yet, right? The IP, the DNS name and the name, right? And then lots of interesting data that's going to get blown up, all of these certs that will not exist soon. But again, remember the stuff that I was showing you in the spec, the YAML file before we started this whole journey. The things about the CIDR block, the admin kube config, the service domain, so on and so forth, right? So clearing my screen again because life is great. We all like, now let's check out machines, right? So it's created 2 machines, right? And we can actually see like the machines exist, they have provider IDs, right? I can introspect on these things and get really interesting information if I can copy it properly. kubectl, now I'm gonna do a describe if I can spell correctly, and machine, boom, right? So again, it tells me versions of the kubelet, the size of the VMs, different information about like the running state of the machine, the public key, and some more information about. So it's chosen an availability zone. It sets some labels, right? This is the annotation that happens to allow it to proceed to the next step. And what we're investigating right now is how cloud providers do labeling and annotation in general, right? And making sure that we can choose, or we can come to some consensus about like what the source of truth should be if we're leveraging the Azure cloud provider and cluster API at the same time, right? There will eventually be a tagging interface where you'll be able to tag things on Azure, and we'll query the tags to define some behavior, or to see if some behavior has been defined, right? So things like have you provided your own resource group, right? So the resource group would say like managed is no, right? So when the provider sees it, it goes, okay, I'm not going to bother to create this resource group because it should already exist, right? I'm going to plop all the resources into that group instead. So lots of like nice little information about trying to do this without, I don't think there's anything super, okay, right. So, yep, there you go.
Nope, there is. Be cautious. I was going to say, be cautious.
Yeah. Yeah, for the machine that is about to die. So, but anyhow, again, this is the stuff that was provided in the spec, the offer, publisher, SKU, version for the images, the location, the disk sizes, and the OS type, right? So all the things that you would need to create resources within Azure, right? Right. And we should see that, boom, done. I said 20 minutes, we got 16 minutes.
Even better.
Yay.
So then can you take us into Azure and like the Azure console and show off the things that were created there?
Sure thing.
Holy crap, look at all that stuff.
Whoa, we got clusters.
And all of these things were deployed programmatically using Cluster API, and I think that's really neat.
Yeah. Boom, drops mic.
Yeah. That's awesome, dude.
So any questions?
No, great job on that demo. Like there was a lot of stuff that was happening, and you explained all of it really, really well. Like that was great. So
some of the curious things that I was talking about showing, thank you, by the way, I meant to say thank you.
You're welcome.
So we've got the actuator, right? And the actuator kind of like kicks off the flow, right? You create a new actuator, it has a reconcile pattern. There's a scope, right? And the scope is kind of cool, right? Because your scope is going to kind of slurp the provider spec and status. It's going to grab an authorizer that will be used for Azure, like to authorize against Azure. It checks for your subscription ID within the environment, right? And then what it'll spit out for you is a set of Azure clients, right? So these Azure clients here are, come on. Okay, so again, include that scope of the subscription ID and authorizer. I forgot that we refactored that. And then a little lower down, we see that we have the cluster client, right? So the interface to do actions over the cluster, the config that we were talking about again, that and then the provider spec, right? The provider spec and the provider status, right? So we've got some of these methods that are made available operating over the scope, right? Being able to pull out information about the network, right? So like I was saying about the network, right? It's how do we want to describe what an Azure network looks like, right? So right now we describe it as, I've got some security groups, I've got a load balancer, I've got an IP, right? Pretty simple. Like these are only the things that I need to care about within the context of the cluster, right? But we're also able to pull out other information, right? Like the subnets, the VNet, the security groups, namespace, location, right? And then finally, we've got these methods to store the cluster config and the status, and a close method which operates over that stuff. So you'll see that within the actuators, we'll do a defer close at the beginning or close to the beginning, right? And it'll kick off a reconciler, right? And this reconcile, so once this reconcile is successful, it'll hit this close, and that close will make sure that I've stored information about the cluster config, anything that I've changed along the way during the reconciliation, and the cluster status, right? So this reconcile, this is where the magic happens, right? So again, this reconciler struct is instantiation of a bunch of these Azure services that I need to operate over the cluster. And then the reconciler is like, okay, let's actually create a new, a new service of each of these individual services for Azure. This is a little different from the AWS stuff because, so AWS primarily, they only need the EC2 and the ELB API. And so we had to build a little extra sauce to be able to pop all of these, clients in easily. Anyhow, the reconcile, right, will do a few things. I will check to see if I can grab the API server IP, right? Because we need this for various things like, pushing this into certs, being able to generate the kube config, being able to know how to access the cluster in general, right? So each of these run a create or update, right? So I'm going to try to create or update these certificates. Some of this package is being refactored to adhere to a reconcile model as well. So instead of create or update, I want to get them. I want to retrieve them from someplace if they already exist, right? So in the instance of certs, I think we're going to investigate looking at storing, generating the certs and then storing them in Azure Key Vault, right? And then popping them out when we're requesting certs, right? Same with this group service create or update, right? This will become a reconcile method where if the resource group exists or it has been provided, I just want to get it, right? If the name isn't within the struct or something like that, then I should create it, or the ID isn't in the struct, which means I can't get the ID because the object doesn't exist yet. So go create it and then write the ID back to this struct, right? So we have a few things that are generating like the VNet names. We have the spec that we shoot into this create or update method, and it kind of like it's the pattern is pretty similar. Like we're defining some spec, and then we're saying do a create or update, right? These will all be reconciles eventually, right? So get it if we have it. If we can't find a way to find it within the scope of the cluster, then I want you to go create it, right? And then finally, then we have this delete flow, which basically does all of that stuff in reverse, or undoes all of that stuff in the reverse order, right? So nothing too exciting. Well,
Yeah, it just cleans it up. Yeah,
it's exciting to me.
Oh, it's interesting stuff. I mean, yeah. Oh, no, go ahead.
And then, you know, we have like the way, so afterwards we have like some converters, right? Or one converter right now, which is commented out the wazoo, which basically takes the known Azure type, right? So the compute.virtual machine, right? With all of this fun pointer stuff to handle, and will return a concrete internal representation of what a VM is to us, right? So the way we define a VM is slightly different from the way Azure defines it. And part of the reason for that is like, one, we don't need all of the bells and whistles that Azure has to represent what a VM is, right? And two, it's nice if we have strings that we can pass around strings instead, right? Or things that break down into like easy types to handle instead of pointers based on like virtual machine extension, right? So then I've got to do some like gymnastics to represent that in the code, right? So prefer not to do that. So we have converters here, and basically these converters will, some of this is not wired up yet, but essentially what the converter is supposed to do is one, convert to that, so our concrete internal representation of what that type should be, and then it will, so Ace, the stuff that you were running into, if you're still on the call, it's within this ZZ generated deep copy file, right? So a bunch of the types like will expose like deep copy and deep copy into methods for each of these types, right? So after the conversion, then I want to deep copy that information back into the scope, right? So that the next reconcile that runs, it's like, oh, I have the ID. Okay, cool. I don't need to do anything, right? You know, so being able to store that information and have like a true view of the world, right? Instead of getting, so we can minimize the calls that we make to Azure by doing that, right? So if anyone is interested in, I don't know if John, you can pull up some of that, like that PR and some of the discussion, or my chatting with myself essentially on that issue.
So we should probably get to any like questions or any like discussion around the Azure provider, because we are coming close to time.
Oh, well, I don't know. Yeah, someone else wants to go to.
No, go ahead, Ace.
Yeah, so I mean, we're talking about the pivot, right? And you were saying there's kind of almost like a 2-point pivot where it's from the kind cluster into Azure, and then from that cluster, you could spawn further clusters. But like, there's no reason if you want it. Okay, so for some context, like the situation we're trying to try is we have 23 clusters, and we want like some kind of declarative management like story for them, right?
Right.
So ideally, we would either have like one cluster that's kind of our control plane, or we would just like bootstrap all of them individually using kind. So I'm curious why you're saying there's like, is the idea that would just be to bootstrap like kind of a control plane?
So yeah, so you, like while there are 2 points to it, only one of them is happening within the cluster CTL run, right? And that's the pivot from kind into this new cluster, right? From there, if you decided that cluster is going to be your management cluster for everything else, totally fine, right? Then you don't need to deal with kind anymore. You just, the same way we did generation of the manifests, right? You generate the manifests, you run the cluster CTL on the target cluster instead.
Right. I guess as a minor follow-up then, the cluster that kind builds, when kind is like done, that cluster is kind of working, but it's basically just the masters. Then that cluster goes and the Azure controller will add the actual like worker nodes to it. Is that kind of a correct understanding?
Right. So there's a machine list that's defined.
Yeah. So V1 Alpha 1 will create the goal for V1 Alpha 1 is HA, if I recall, or is that V1 Alpha 2, Stephen?
My goal is one control plane, one node. So there,
Yeah.
so we've reached my very low bar.
Yeah.
I think that the next thing that we will want to attack is overall we need increased test coverage. I need to write end-to-end tests, because like sometimes I can only discover these things after like, oh well, let me try that out by building a cluster, right? So all of these things that we just went through, I would have to do, right? Or quit our cluster CTL as it's running so that kind stays up and I can introspect into that cluster. I can play around, I can start like swapping images out and do stuff like that. But there's a bit of lead time in like being able to find out new information by making changes, right? So by having periodic end-to-end tests that run in the in the Kubernetes test infra, like one, then I don't have to deal with it, right? And two, we're actually getting signal on the changes that are happening across master. So that I think now that we've gotten to the point where we're like, okay, we just need master to work. Now that we've gotten past that point, we're like, okay, well, what do we have to do to be like a sane a sane implementation of this provider? So definitely increase the test coverage, definitely start to do more exploration around availability zones, right? So making sure that everything that we build is zone redundant. I think that's mostly true right now, or if not totally true already. And I think that there needs to be some flexibility in the way people deploy, right? So try to dredge up the common patterns for users, right? So one being, I might not have access to create a resource group, right? Based on my company's policy, right? So we need to support existing resource groups, right? And I may not want to build the network myself, but we may already have a network built, and I want to supply it over time, right? So one of the discussions that we were having, and again, it's like me chatting with myself. It's on an issue somewhere about supporting existing VNets, and one of the things that you run into is, as I was writing some of that code, I was like, oh well, if we support existing VNets and we say the VNet's provided, right, then are we still going to create the subnets? If we are going to create the subnets, that means I need to figure out what the CIDR block is for the VNet, right? And then do some magic to do some subnet math to understand, like, okay, well, how am I going to structure these subnets, right? I also need to retrieve a set of the subnets that already exist within that VNet and make sure that the subnets that I'm going to create for the control plane and the node don't conflict with those CIDR ranges, right? Because that's a spurious error that will pop up in Azure that I discovered, that I was like, oh, this error doesn't really tell me anything about what's going on. It just says like net config invalid subnet, right? And not the fact that the subnet range overlaps with something else, right? So starting to do things like that will tease out some of the common user use cases. I think like existing resources and existing VNets are two big things to handle next, and those are things that I'm trying to land before the 0.20 release. And then I think we can improve some of the tooling, that we have, like the mock generation, the generation of manifests in general. There's some, AWS uses a helper called cluster AWS ADM, right, which allows you to like generate the IAM roles that are required to run on AWS. So we want to do some of that stuff too, and then we also want to figure out like what we can get away with, like the level of permissions that we can get away with granting to the user. Right now, we're assuming that you're coming to the table with a service principal that has contributor access, right? And like however you get that is like, that's an exercise left to the user, right? But we're assuming that you have contributor access, right? Again, that's not the state of the world, right? You won't always have contributor access in service principals, right? So we need to be able to structure policies and figure out exactly all of the different tools that we need. Like we need to create VNets, we need to create subnets. Like, so going down that ladder and kind of like enumerating those cases, and then building a tighter security model around some of this stuff. But I actually forgot what the question was. I just started yammering. So
it was about HA nodes.
HA nodes, yes. So HA nodes, if we can get a separate work stream going, if someone is interested in taking on HA nodes, totally happy to, like, again, PR is welcome, issue is welcome.
Yeah, but yeah, like as Steven said, like right now what we're doing is one control plane, one node. Anybody else? Anybody some thoughts on Cluster API or Azure? Or any thoughts on the program? Did you guys have fun? Because I always enjoy this.
This was excellent.
I'm having a terrible time. No.
That's crazy.
So there was a question in the chat regarding
I can see chat.
Yeah, regarding the reconcile, if it tries to create if some resource has not been created yet, but once it's done, it'll store the status that it's been created. But if the resource goes down on the cloud provider side, the reconcile won't try recreating it, right? It depends. It depends is the answer. Part of our current issue is that we don't have a true internal representation for all of the fields that we need to determine that. Right. So the things I was talking about, like supporting existing resource groups and supporting existing VNets, right? So right now a resource group exists as a string, right? Which means I can't like encode any like cool Azure information about it. It's just like rainbow sparkles, cool. Okay, right. So the next PR that I have coming is like, okay, well now resource group is a struct, right? And it contains the name of the resource group, the ID, and a managed flag, right? So if manage is set to yes, if manage is set to yes, then it'll say, okay, well, I need to create this. If manage is set to no, then it will go, okay, well, we're going to skip this entire flow, right? Because you said you didn't want me to do anything about it, right? So it will depend on whether you decided to provide that resource or not. And then secondarily, there are, like I think there's a balance between giving people levers or knobs to tweak and providing like a consistent framework to build something, right? So there are certain things that we're never going to allow you to mess around with, right? So if we decide that you are going to bring your own VNet, then guess what? We're not going to mess around with your security groups. We're not going to try to mess around with the subnets. We're not going to mess around with anything related to that, right? So we need to be able to break out of those cases quickly within the code, right? And then and then there's certain things that we're like, okay, we'll absolutely have to manage these, because if we don't, like, you won't get a cluster, right? Right. So I think we're still investigating like how to strike the balance between those two things. I think that the resource groups and VNets are a good first target, because those are the things that usually come up first, right?
Cool. All right. Well, thank you so much, Stephen, for giving us such a deep dive and a demo into the Azure provider. That was awesome. Again, really great work getting this across, like, to this, not even the finish line. We're not done, right? There's always going to be work to do, right? But to get it to this point, that was awesome.
Thank you. Thank you.
I'm curious, of all the people who are left, who is not part of VMware? Is everyone VMware?
No, Brad's IBM.
Okay, cool. I wanted to make sure like that the link that's sent out was working. I was kind of like, I saw a lot of VMware people, so I was like, wait, was there not a lot of public?
So I think one of the posts was
Got deleted.
Yeah, I think the link was broken. Yeah, I think the link was broken in one of the posts as well. So the most recent one that came out. So I responded to that post with the correct link and shouted in the channel. So we had a few people that were not VMware.
Okay, cool. I just wanted to make sure, and I was just curious myself, like.
I wonder how many people traveled back in time to attend that first one.
Yeah, right. Yeah, because the first post was like set for like March 12th.
That's the project I want to work on.
Cool. All right. Thank you everyone for joining. I had a lot of fun, and I hope you did too. Join us in a couple weeks when we do the next Cloud Native Social Hour, and I'm not sure on what topic yet. We'll figure it out.
If you have ideas, let us know.
Yes. Yeah, please let us know. Reach out to us on Twitter. I'm at API Nick. And we will, if you want to do a demo, I would love to have people do demos. Or if you want to talk about a specific topic, let us know. We will do these things. Because remember, this is your Cloud Native Social Hour. All right. Bye.
Happy Friday, everyone. Bye.
Happy Friday.